February 18, 1943, dawned cold over the Kasserine Pass in Tunisia, where German panzers had just shattered the American II Corps in what would become the U.S. Army's first major engagement against Nazi Germany in North Africa. Oberst Rudolf Lang of the Afrika Korps crouched beside a knocked-out American half-track, his experienced eyes scanning the battlefield debris that littered the rocky terrain. The Americans had retreated in chaos, leaving behind not just vehicles and ammunition, but something far more intriguing. A lightweight weapon that would change German infantry tactics for the remainder of World War II. Lang picked up the M1 carbine from beside a fallen soldier's position, turning the compact rifle over in his gloved hands. After years of handling the cumbersome Carabiner 98K, the standard German infantry rifle that weighed nearly 9 pounds and stretched 43 inches long, this American weapon felt revolutionary. The carbine weighed barely 5.5 pounds, measured just 35 inches, and possessed a handling quality that immediately impressed the veteran officer. According to historical accounts documented in the U.S. Army's official history of the North African campaign, German forces captured significant quantities of American equipment at Kasserine, including numerous examples of the newly issued M1 carbine. The weapon represented everything German ordnance officers had been discussing in theoretical terms since the invasion of Poland. Wehrmacht soldiers had spent 4 years of warfare lugging around full-power rifles designed for engagement ranges of 800 meters or more. Yet combat reports consistently showed that most infantry firefights occurred at distances under 300 meters. The Carabiner 98K fired the powerful 7.92mm Mauser cartridge, which delivered devastating long-range accuracy, but came with punishing recoil and limited the rifle's magazine capacity to just 5 rounds. Lang worked the carbine's action, noting the smooth 15-round detachable magazine and the gentle recoil he'd heard described by soldiers who'd picked up similar weapons from American positions. This wasn't just another enemy rifle to be catalogued and forgotten. This represented a completely different philosophy of infantry armament. The Americans had created what German weapons designers called a Mittelpatrone, an intermediate cartridge that bridged the gap between pistol ammunition and full-powered rifle rounds. Within hours, Lang's discovery began its journey up the chain of command. General Lieutenant Heinz Ziegler, responsible for Wehrmacht weapons procurement in North Africa, examined the carbine with growing fascination. The weapon fired the .30 caliber carbine round, a cartridge that generated far less recoil than standard rifle ammunition, while still maintaining effective lethality at combat distances. More importantly, the reduced recoil and lighter weight meant soldiers could carry more ammunition and engage targets more rapidly. Ziegler immediately ordered all captured M1 carbines to be shipped to the Heereswaffenamt, the German Army Weapons Agency, in Berlin for comprehensive evaluation. The samples arrived at the testing facilities in early March, where engineers subjected them to rigorous analysis. They measured every dimension, tested the gas-operated action, evaluated the sight system, and most critically, studied the ballistic properties of the intermediate power cartridge. The German weapons establishment had been searching for exactly this solution since 1942, when reports from the Eastern Front made clear that the standard bolt-action rifle was becoming obsolete in modern warfare. The American carbine provided a working blueprint for the future of infantry weapons, and Germany was about to exploit it on a massive scale. By March 1943, the Wehrmacht faced a tactical dilemma that had been building since the opening days of Operation Barbarossa, nearly 2 years earlier. German infantry squads structured their firepower around a single MG-34 or MG-42 machine gun, with riflemen serving primarily to protect the gunner and carry ammunition. This doctrine had proven effective in the swift victories of 1939 through 1941, but the grinding attritional warfare of the Eastern Front exposed critical weaknesses in German small arms doctrine. Hauptmann Wilhelm Schulz, a company commander who'd fought from Stalingrad to Kursk, articulated the problem in his after-action reports that now resided in Wehrmacht archives. His riflemen carried weapons optimized for precision shooting at ranges that rarely occurred in actual combat. When Soviet troops launched close-range assaults through forests, urban ruins, or trench systems, German soldiers found themselves cycling bolt actions against enemies armed with PPSH-41 submachine guns that could unleash 900 rounds per minute. The imbalance was killing experienced soldiers who couldn't generate sufficient return fire during critical moments. The Heereswaffenamt had recognized this problem and commissioned development of the Maschinenpistole 43, a submachine gun intended to give German infantry more automatic firepower. However, submachine guns fired pistol ammunition that lacked effective range beyond 100 meters, creating a different set of limitations. What the Army truly needed was something between a submachine gun and a rifle, exactly what the Americans had apparently created with their carbine concept. When the captured M1 carbines reached the testing grounds at Kummersdorf, south of Berlin, Oberingenieur Louis Schmeisser led the evaluation team that would determine their significance. Schmeisser came from a legendary family of German weapons designers. His father, Hugo Schmeisser, had pioneered automatic weapons development during World War I. The younger Schmeisser possessed both theoretical knowledge and practical experience in firearms engineering, making him ideally suited to understand what the Americans had achieved. The testing process consumed 3 weeks of intensive analysis. Engineers fired thousands of rounds through multiple carbine examples, measuring accuracy, reliability, and performance under various conditions. They discovered that the .30 caliber carbine round generated approximately 1,300 foot-pounds of muzzle energy, substantially more than pistol ammunition, but significantly less than the nearly 3,000 foot-pounds produced by standard rifle cartridges. This intermediate power level created what Schmeisser called the optimal balance for infantry combat. Most significantly, the reduced recoil impulse of the carbine round meant that even a relatively lightweight automatic weapon could remain controllable during sustained fire. This observation connected directly to ongoing German development projects that had been struggling with exactly this challenge. Since 1941, designers at C.G. Haenel in Suhl had been working on an automatic rifle called the Maschinenkarabiner 42, which used a shortened version of the standard Mauser cartridge. The MKB-42 showed promise, but suffered from excessive recoil and reliability issues, stemming from the still powerful ammunition it fired. Schmeisser's report to the Heereswaffenamt in late March 1943 proved decisive. He concluded that the American carbine concept validated the entire intermediate cartridge philosophy and recommended immediate acceleration of German development programs along similar lines. However, the German approach would be more ambitious than the American design. Rather than creating a semi-automatic carbine for specialized troops, Germany would develop a fully automatic assault rifle for frontline infantry, a weapon that would eventually be designated the Sturmgewehr 44. The captured American weapon had provided the proof of concept, but German engineers intended to take the idea much further, creating what military historians would later recognize as the first true assault rifle ever issued to a national army. April 1943 brought renewed urgency to German weapons development, as Schmeisser's team accelerated their work on what they internally designated the Maschinenkarabiner 43. The project operated under intense pressure from both the Heereswaffenamt and increasingly from Adolf Hitler's headquarters, where the Führer had become personally interested in new weapons that might reverse Germany's deteriorating strategic position. Following the disaster at Stalingrad in February and the surrender of the Afrika Korps in Tunisia by May, Germany desperately needed technological advantages to compensate for the Allies' growing numerical superiority. The development team at C.G. Haenel in Suhl, working alongside engineers from Walter, faced the challenge of creating an entirely new cartridge from scratch. While the captured American carbine provided inspiration, German designers believed they could improve upon the concept by developing a more powerful intermediate round. They created the 7.92 by 33 mm Kurz cartridge, Kurz meaning short in German, which generated approximately 1,600 foot-pounds of energy, splitting the difference between the American carbine round and full-power rifle ammunition. Hugo Schmeisser, Louis' father, took direct control of the mechanical design process. At 62 years old, he brought nearly 4 decades of weapons engineering experience to the project. The elder Schmeisser had designed the Bergmann MP-18, the world's first practical submachine gun, during World War I, and his expertise in automatic weapons proved invaluable. He conceived a gas-operated action that fed from a 30-round detachable magazine, incorporated a selective fire mechanism allowing both semi-automatic and fully automatic fire, and kept the overall weight under 11 pounds when loaded. By July 1943, functional prototypes underwent field trials on the Eastern Front, where Waffen-SS units received the first examples for combat evaluation. Sturmbannführer Hans Kempen commanded one of the test units that received 50 pre-production rifles near Kharkov. His reports, preserved in captured German documents, expressed enthusiasm bordering on reverence. The new weapon allowed his soldiers to deliver aimed automatic fire at ranges up to 400 meters, something impossible with submachine guns yet far more practical than slow-firing bolt-action rifles. Kempen particularly noted the weapon's performance during Soviet infantry assaults. When Red Army troops attacked in their characteristic waves, German soldiers equipped with the new rifles could engage targets rapidly, shift fire between multiple enemies, and reload quickly using the detachable box magazines. The combination of automatic fire, intermediate power ammunition, and manageable recoil created a firearm that finally matched the tactical reality of modern infantry combat. Casualty ratios in Kempen's company improved dramatically compared to units still armed with traditional Karabiner 98K rifles. The successful field trials triggered intense debate within the German High Command about production priorities. By August 1943, multiple German weapons manufacturers stood ready to begin mass production, but the project faced an unexpected obstacle: Adolf Hitler himself. The Führer, influenced by conservative ordnance officers, initially dismissed the new rifle as unnecessary. He believed the standard rifle and machine gun combination remained adequate and worried that introducing a new cartridge type would complicate Germany's already strained logistics system. This opposition forced Hugo Schmeisser and the development team to employ creative tactics. They redesignated the weapon from Maschinenkarabiner to Maschinenpistole 43, deliberately using the submachine gun designation to avoid Hitler's prohibition on new rifle development. Under this bureaucratic camouflage, production began in limited quantities at multiple facilities. The deception reflected the desperate nature of Germany's military situation. By late 1943, weapons designers were literally hiding development programs from their own supreme commander. The captured American carbine from Tunisia had set in motion a chain of events that would revolutionize infantry warfare, even as Germany's ability to exploit this revolution diminished with each passing month of the war. September 1943 marked a turning point in the secret production program when Joseph Goebbels, the Reich Minister of Propaganda, intervened on behalf of the new rifle. Goebbels, despite his primary responsibility for information control rather than military procurement, had received enthusiastic reports from Waffen-SS units using the weapon and recognized its propaganda value as a miracle weapon that could bolster civilian morale. He arranged for Hitler to view a carefully staged demonstration at the Führer's headquarters in East Prussia, where hand-picked soldiers showcased the weapon's capabilities against various targets. The demonstration took place on October 12, 1943, at Wolfschanze, the Wolf's Lair, Hitler's military headquarters. General Oberst Heinz Guderian, recently appointed Inspector General of Armored Troops, attended alongside Albert Speer, the Minister of Armaments and War Production. The demonstration team set up targets at ranges from 50 to 300 meters, showcasing the rifle's accuracy in both semi-automatic and fully automatic modes. Soldiers fired from standing, kneeling, and prone positions, demonstrating the weapon's superior handling characteristics compared to the unwieldy Karabiner 98K, declared that the weapon should be officially designated the Sturmgewehr 44, and authorized its production as a top priority. This reversal transformed the program from a partially concealed development project into a major industrial undertaking. Speer's Ministry of Armaments immediately allocated resources for mass production across multiple facilities. C.G. Haenel in Suhl served as the primary manufacturer, but contracts also went to Mauserwerke in Oberndorf, Steyr Daimler Puch in Austria, and other firms. The goal was to produce sufficient quantities to rearm significant portions of the Wehrmacht's infantry forces before the anticipated Allied invasion of Western Europe. The production ramp-up occurred against a backdrop of increasing Allied bombing raids that targeted German industrial capacity. By December 1943, the Allies had launched their combined bomber offensive, systematically attacking German manufacturing centers. Weapons production facilities received high priority as targets, forcing German planners to disperse manufacturing across numerous smaller workshops and underground facilities. The Sturmgewehr production program suffered delays as machinery and skilled workers were relocated to less vulnerable locations. Despite these challenges, monthly production figures steadily increased throughout late 1943 and into 1944. By January 1944, German factories were producing approximately 5,000 Sturmgewehr 44 rifles per month. This rate increased to 10,000 per month by March and reached peaks of 30,000 per month by June 1944, coinciding with the Allied invasion of Normandy. However, these production numbers remained far below what German planners had originally envisioned. The industrial mobilization required to produce the Sturmgewehr 44 involved not just manufacturing the rifles themselves, but creating an entirely new ammunition production infrastructure. The 7.92 by 33 mm Kurz cartridge required new tooling, quality control procedures, and distribution systems. German ammunition plants at factories in Magdeburg, Dresden, and other cities retooled production lines to manufacture millions of rounds of the new intermediate cartridge. This logistical undertaking strained Germany's already overstretched industrial capacity and diverted resources from other critical war material. By mid-1944, the program had produced approximately 100,000 Sturmgewehr 44 rifles, with hundreds of thousands more in various stages of manufacturing. The weapon that began as an examination of a captured American carbine in Tunisia had evolved into Germany's bid to maintain infantry superiority through technological innovation. However, Germany's deteriorating strategic situation meant that even revolutionary weapons technology could not reverse the fundamental arithmetic of Allied material superiority in Germany's shrinking territory and industrial base. June 6, 1944, D-Day, brought the anticipated Allied invasion of Normandy, and German defenders included some units equipped with the new Sturmgewehr 44. Oberst Wilhelm Wiebig commanded Grenadier Regiment 919, positioned near Carentan, and his regiment had received approximately 200 of the new rifles in late May. These weapons represented less than 20% of his unit's total firearms, but their impact on combat effectiveness proved disproportionate to their numbers. The Normandy fighting immediately demonstrated the Sturmgewehr's tactical advantages. During the hedgerow warfare that characterized combat in the Norman bocage, engagement ranges rarely exceeded 150 meters. The close terrain negated the theoretical range advantages of traditional rifles, while favoring weapons that could deliver rapid fire during sudden close-range encounters. Wiebig's soldiers armed with Sturmgewehrs consistently outperformed those carrying standard Karabiner 98K rifles in these conditions. American forces, ironically, still carried the M1 carbine that had inspired the German development program, alongside the M1 Garand rifle and various other weapons. Combat encounters between Sturmgewehr-armed Germans and American troops created a complex tactical dynamic. The Sturmgewehr delivered fully automatic fire, which the semi-automatic M1 carbine could not match, but American units typically possessed greater overall firepower through superior numbers and supporting weapons. German commanders noted in after-action reports that the Sturmgewehr allowed smaller German units to hold positions longer against numerically superior Allied forces. By August 1944, Sturmgewehr production had reached its peak monthly output of approximately 30,000 units. However, this production rate, while impressive given Germany's deteriorating industrial situation, remained far below initial projections. The original plan called for producing 50,000 rifles per month by mid-1944, with goals of eventually replacing all standard rifles in frontline infantry units. The reality of Allied bombing, resource shortages, and labor problems meant these targets were never achieved. The Eastern Front received priority for Sturmgewehr distribution, where German forces faced overwhelming Soviet numerical superiority. By September 1944, entire companies within some Wehrmacht divisions had converted to the new weapon. Hauptmann Rudolf Petersen commanded such a company in Heeresgruppe Nord, and his reports to division headquarters described the Sturmgewehr as the only weapon that allows our soldiers to fight on equal terms with Soviet troops armed with submachine guns and automatic rifles. The weapon's 30-round magazine capacity proved particularly valuable during Soviet offensive operations, when Red Army units attacked in successive waves. German soldiers could maintain sustained fire without the constant reloading required by bolt-action rifles or the limited range of submachine guns. The 7.92 by 33 mm Kurz cartridge provided sufficient power to engage targets effectively at combat ranges, while generating manageable recoil that allowed accurate automatic fire. Production continued despite increasingly chaotic conditions in Germany throughout late 1944. As Allied forces advanced from the west and Soviet armies pushed from the east, weapons manufacturing faced constant disruption from bombing raids, transportation breakdowns, and labor shortages. Many plants operated underground in mines and caves, where workers assembled rifles under primitive conditions. Quality control suffered, and reliability problems plagued rifles produced during this period, though the basic design remained sound. By December 1944, cumulative production had reached approximately 250,000 Sturmgewehr 44 rifles. This represented a significant accomplishment given Germany's circumstances, but remained far short of the revolutionary impact German planners had envisioned. The weapon had demonstrated its superiority over traditional infantry rifles, validating the intermediate cartridge concept that the captured American carbine had inspired. However, Germany's strategic collapse meant that superior individual weapons could not reverse the outcome of the war. The final months of Sturmgewehr production would occur against the backdrop of Germany's total military defeat, even as factories continued manufacturing the revolutionary rifle that had come too late to matter. January 1945 found German weapons production entering its death throes as the Third Reich contracted under relentless Allied pressure from all directions. Soviet armies had launched their Vistula-Oder offensive on January 12th, advancing rapidly across Poland toward Germany's eastern border. In the west, Allied forces were recovering from the Battle of the Bulge and preparing renewed offensives toward the Rhine River. Despite this catastrophic strategic situation, Sturmgewehr 44 production continued at several dispersed facilities that had survived the Allied bombing campaign. The Mauser-Werke facility in Oberndorf, located in southwestern Germany, maintained production through February 1945, despite increasingly irregular supplies of raw materials and components. Factory director Hermann Müller documented the chaotic conditions in internal memoranda that Allied investigators later discovered. Electrical power operated only intermittently, forcing production lines to halt for hours or days. Transportation networks had collapsed to the point where finished rifles sometimes sat in warehouses for weeks awaiting rail cars that never arrived. Workers, many of them forced laborers from occupied territories, operated under malnutrition and constant fear of Allied air raids. The Steyr plant in Austria faced similar challenges but maintained production until March 1945. By this point, quality control had deteriorated significantly from the high standards of 1943. Rifles produced during these final months often featured crude machining, improvised parts, and simplified construction techniques designed to reduce manufacturing time. Some examples eliminated cosmetic features like bayonet lugs or cleaning rod channels to accelerate production. Despite these shortcuts, the essential operating mechanism remained effective, and these late-war Sturmgewehrs functioned adequately in combat conditions. Albert Speer, whose ministry nominally controlled weapons production, had effectively lost contact with many manufacturing facilities by March 1945. His diary entries from this period, published decades after the war, reflected the surreal nature of attempting to coordinate industrial production as Germany disintegrated. Speer recorded that production figures reported through official channels bore little resemblance to reality, as factory managers inflated numbers to avoid punishment, while actual output plummeted. The true production rate of Sturmgewehr, 44 rifles during the final months of the war, remains uncertain, though estimates suggest approximately 20,000 additional units were completed between January and April 1945. These final rifles reached combat units through increasingly improvised logistics networks. Many were distributed to Volkssturm units, the German Home Guard formed in autumn 1944 from men previously considered too old or unfit for military service. The contrast was stark. revolutionary assault rifles in the hands of poorly trained civilians and teenagers defending Germany's last territories. Combat reports from this period describe Volkssturm detachments achieving temporary local successes when armed with Sturmgewehrs, only to be overwhelmed by Allied superiority in numbers, artillery, armor, and air support. The C.G. Haenel plant in Suhl, where Hugo Schmeisser had overseen the weapon's development, continued operations until April 13, 1945, when American forces captured the town. Allied intelligence officers who examined the facility discovered production records indicating the plant had manufactured approximately 43,000 Sturmgewehr 44 rifles between October 1943 and April 1945. These records also revealed that Schmeisser's team had continued development work on improved versions even as Germany collapsed, designing refinements that would never see production. By late April 1945, as Soviet forces encircled Berlin and American units advanced through southern Germany, weapons production had ceased at virtually all remaining facilities. The final confirmed Sturmgewehr 44 emerged from a workshop in Sudetenland on April 27, 1945, just days before Germany's unconditional surrender. Total production figures compiled from captured German records and Allied intelligence assessments indicated that approximately 425,000 Sturmgewehr 44 rifles had been manufactured between mid-1943 and Germany's surrender in May 1945. This number fell dramatically short of initial projections, but represented a remarkable achievement given Germany's circumstances during this period. The production program had created hundreds of thousands of the world's first true assault rifle, validating the intermediate cartridge concept and establishing design principles that would dominate infantry weapon development for the next 80 years. The weapon that began with examination of a captured American carbine in Tunisia had evolved into Germany's most significant contribution to firearms technology, even though it came too late and in insufficient numbers to affect the war's outcome. May 8, 1945 marked Germany's unconditional surrender, ending the European theater of World War II. Within days, Soviet intelligence teams fanned out across occupied German territory with specific instructions to locate and seize advanced weapons technology. Among their highest priorities was the Sturmgewehr 44, which Soviet forces had encountered frequently during the final year of fighting. Red Army soldiers had captured thousands of the German assault rifles, and Soviet commanders recognized that Germany had developed something genuinely revolutionary in infantry weapons. Major General Anatoly Blagoravov headed the Soviet Technical Intelligence Mission assigned to investigate German small arms development. His teams descended on the now-abandoned C.G. Haenel plant in Suhl, which fell within the Soviet occupation zone. There they discovered not only remaining stockpiles of Sturmgewehr 44 rifles and ammunition, but also complete technical documentation, manufacturing drawings, and perhaps most importantly, Hugo Schmeisser himself. The elderly weapons designer had remained in Suhl after the American capture, and the Americans had transferred him to Soviet custody when zonal boundaries were finalized in July 1945. Soviet engineers immediately began systematic analysis of the Sturmgewehr design. Senior Lieutenant Mikhail Kalashnikov, a tank commander who had turned to weapons design after being wounded in 1941, participated in these evaluations at a testing facility near Moscow. Kalashnikov, then 26 years old, had already submitted several weapon designs to Soviet authorities, though none had yet entered production. His exposure to the German assault rifle would prove decisive in his subsequent career. The Soviet Union faced its own infantry weapons challenges that closely paralleled Germany's earlier situation. Soviet troops primarily carried the Mosin-Nagant rifle, a bolt-action design dating to 1891, alongside various submachine guns like the PPS-41. This combination mirrored the German predicament that the Sturmgewehr had addressed, a gap between short-range automatic weapons and long-range rifles, with no effective firearm optimized for the actual engagement distances of modern combat. Throughout late 1945 and into 1946, Soviet weapons bureaus studied the Sturmgewehr 44 alongside captured documentation and interrogation reports from German engineers. Hugo Schmeisser, along with several other members of his design team, was compelled to work for Soviet ordnance programs at a facility in Ijevsk. The Soviets were particularly interested in understanding the intermediate cartridge concept and the gas-operated action that made automatic fire controllable. Kalashnikov's design bureau received specific direction to develop a Soviet assault rifle incorporating lessons from the German weapon. However, Soviet leadership insisted on creating an original design rather than simply copying the Sturmgewehr. This decision reflected both practical considerations — Soviet manufacturing capabilities differed from German practices — and ideological factors. Stalin's regime sought to demonstrate Soviet technological independence and superiority over the defeated Germans. The Soviet development program created its own intermediate cartridge, designated 7.62 by 39 mm. This round resembled the German 7.92 by 33 mm Kurz in concept, though Soviet designers optimized their cartridge for slightly different ballistic characteristics. The 7.62 by 39 mm would eventually become one of the world's most common rifle cartridges, manufactured in quantities exceeding 100 billion rounds over subsequent decades. Kalashnikov submitted his assault rifle design in competition with proposals from other Soviet weapons designers, including Alexei Sudayev and Sergei Simonov. The testing program extended through 1946 and into 1947, evaluating competing prototypes under severe environmental conditions. Soviet testers subjected the weapons to mud, sand, extreme cold, and deliberate abuse that far exceeded German testing standards. The trials aimed to identify a design that could function reliably under the harsh conditions of Soviet military service, where maintenance standards and spare parts availability often fell below Western levels. By late 1947, Kalashnikov's design had emerged as the clear winner. Designated the Avtomat Kalashnikova 47, the AK-47, the weapon incorporated several distinctive features while embodying the fundamental intermediate cartridge selective fire concept pioneered by the German Sturmgewehr. Soviet authorities authorized production in 1948, and by 1949, the first AK-47s were reaching frontline units. The weapon that would eventually become the world's most common firearm, with production exceeding 100 million units, traced its conceptual lineage directly back to the American carbine captured in Tunisia and the German assault rifle it had inspired. The development arc from the M1 carbine to the Sturmgewehr, 44 to the AK-47, represented a revolution in military technology that fundamentally transformed infantry warfare. By 1950, the basic concept of the assault rifle, an intermediate cartridge selective fire weapon with detachable magazine, had become the recognized standard for infantry armament worldwide. The German production total of approximately 425,000 Sturmgewehr 44 rifles between 1943 and 1945 represented just the beginning of this transformation. Historical analysis reveals the numerical expansion that followed. Soviet production of the AK-47 and its variants eventually exceeded 100 million units, making it the most produced firearm in history. But the influence extended far beyond Soviet manufacturing. By the 1960s, virtually every major military power had adopted assault rifles based on the intermediate cartridge concept. The United States developed the M16, firing the 5.56 by 45 mm cartridge. Belgium created the FN FAL. Britain adopted the EM2, and later the SA-80. Each reflected the same fundamental insight that German engineers had extracted from examining the captured American carbine. The production numbers illustrate the revolution's scale. By conservative estimates, global production of assault rifles and their derivatives between 1950 and 2025 exceeded 290 million units. This figure encompasses not just the famous AK series, but countless variants and competing designs: the Heckler and Koch G3, the Chinese Type 56, the Israeli Galil, the South African R4, and dozens of other national variants. All traced their conceptual ancestry to the weapon developed in response to that February 1943 discovery in Tunisia. The irony embedded in this history deserves acknowledgement. The Americans had created the M1 carbine as a lightweight weapon for support troops, officers, and vehicle crews, soldiers who needed a firearm more capable than a pistol, but less cumbersome than a full-sized rifle. The U.S. military did not envision it as a revolutionary infantry weapon, and continued issuing the 8-pound M1 Garand rifle to frontline soldiers throughout World War II. German designers, under the pressure of military necessity, recognized the broader implications of the intermediate cartridge concept that American planners had overlooked. The American military establishment, despite inventing the weapon that inspired the assault rifle revolution, remained remarkably resistant to adopting the concept for frontline troops. The United States continued fielding full-power rifles through the Korean War and into the early 1960s. Only the Vietnam War forced American acceptance of the intermediate cartridge assault rifle with the M16's adoption, nearly 20 years after Germany had deployed the Sturmgewehr 44. Hugo Schmeisser returned to East Germany in 1952, after his compulsory service to Soviet weapons programs ended. He lived quietly until his death in 1953, largely unrecognized in the West for his role in revolutionizing infantry weapons. His son Louis continued weapons design work in West Germany. The Schmeisser family's contribution to firearms development spanned 3 generations and 2 world wars, but their most influential creation remained the weapon they'd developed under pressure of Germany's deteriorating military situation. The captured American carbine that Oberst Rudolf Lang examined near Kasserine Pass in February 1943 has acquired almost mythological status in firearms history. Various accounts disagree on specific details, exactly who found it, precisely when, under what circumstances. But the fundamental narrative remains consistent. A German officer recognized the significance of American weapons technology, initiated an analysis that led to the Sturmgewehr 44's development, and inadvertently set in motion the transformation of infantry combat worldwide. The production figure of 290 million assault rifles globally by 2025 represents a conservative estimate based on documented manufacturing records, but the true total likely exceeds 300 million when including unlicensed production, small-scale manufacturing, and weapons produced by non-state actors. This proliferation has created complex security challenges, as assault rifles have become the primary weapon of both conventional armies and irregular forces worldwide. The historical trajectory from a single captured carbine in Tunisia to hundreds of millions of assault rifles deployed globally illustrates how military technology evolves through observation, adaptation, and refinement across national boundaries. German engineers studied American design, Soviet designers studied German weapons, and subsequent generations of weapons developers built upon these foundations. The intermediate cartridge assault rifle became universal not through any single nation's dominance, but through the gradual recognition that the German answer to American innovation represented the optimal solution to infantry combat requirements. Today, military historians recognize the Sturmgewehr 44 as one of World War II's most significant technological developments, not for its impact on that conflict. It arrived too late and in too few numbers to matter, but for establishing the template that would define infantry weapons for the next century. The weapon that began with a captured American carbine in the North African desert became the foundation for the most common class of military firearms in human history, a legacy measured not in the hundreds of thousands of German production, but in the hundreds of millions of descendants that followed.